Hello, students of 12th class. So, I am Pardeep Koul, lecturer in chemistry, and I am here with you with unit number 6. And today's topic in this very unit is extraction of zinc. Today, we will extract zinc from its ore. Now, before going to its extraction, let us name some ores of zinc. Zinc has many ores like zinc blende. Zinc blende is one of the ores of zinc having chemical formula ZnS. This is also known as sulfide ore of zinc since it contains sulfur. Then we have another ore of zinc, it is calamine, having chemical formula ZnCO3, that is zinc carbonate. Then one more ore of zinc is zincite, having chemical formula as ZnO. Another ore is willemite, having chemical formula as Zn2SiO4. This is a silicate ore. Then last ore, it is franklinite, having molecular formula ZnO Fe2O3. So these are 5 ores of zinc. Now among these 5 ores, this ore, that is zinc blende, this is the chief ore of zinc. Main ore of zinc is zinc blende, also known as sulfide ore of zinc. Now today we will extract this zinc from this ore, that is from zinc blende. So we will go to the extraction of zinc now from zinc blende. Now for extraction, as you know, there are some steps to be followed. The first step is again very common step in extraction of zinc. Extraction. First step you know is crushing. What we do in this step, we take zinc blende, we crush it in jaw crushers. Jaw crushers. This is mechanical crushing. We do because jaw crushers are basically machines. These jaw crushers crush this ore, that is your zinc blende, and change it into powdered form, and as a result we get powdered ore. So first step is very common in extraction of all metals. This step is common, that we take the ore and we crush it in jaw crushers to get the fine powder known as powdered ore. Then the second step is concentration. As far as sulfide ores are concerned, you must remember that all sulfide ores are concentrated by a method known as froth flotation process. Froth flotation method or froth flotation process. Please remember that sulfide ores are concentrated by this method. What we do in this method, we take this powdered ore obtained in the first step, we mix it with a mixture of pine, oil and water. When ore is mixed with this, what happens? The metal forms the froth. Suppose this is pine oil and water. Basically, a blast of pine oil and water is introduced in the container. Water is already there, so there is oil plus water in it. Now, when ore is introduced in it, and this is subjected to blast. That blast has, as the word suggests, high power, and with that what happens? A froth is formed. That is why the process is known as froth flotation process. Froth floats on the surface, and this froth contains the metal that is zinc. Though not pure, but it contains. While as your impurities, they are heavier, they settle down at the bottom. So what we do, we remove this froth, we just wash it and get the concentrated ore. That is, this ore, the concentrated ore, is not pure. It may contain certain more impurities. So we get concentrated ore as a result of froth flotation process. So this is all about step number 2. Then moving to step number 3. Step number 3 in the extraction of zinc is roasting. Roasting, if you remember, roasting means heating, strong heating rather, not only heating. Strong heating of which ore? The concentrated ore, because in second step we got concentrated ore. Strong heating of concentrated ore in excess of air is known as roasting. So roasting is done by strong heating the concentrated ore, and the temperature that is used in roasting is 1200 kelvins. Now let us go for roasting through a chemical reaction. This is zinc blende ore, that is being from which zinc has to be extracted. It will undergo roasting, it will combine with oxygen at a very high temperature, that is 1200 Kelvin, and as a result our zinc sulfide will change into zinc oxide, like this, twice zinc oxide plus twice sulfur dioxide. This sulfur dioxide can be used for making sulfuric acid, and as a result we get Z and O, that is, it is oxide ore of zinc now, and oxide ore of zinc, you know, is known as zincite. So this is now zincite. Now, so this ore which we receive is known as roasted ore. It still contains impurities. For example, if its chemical formula, if we look at its chemical formula, we find oxygen is there. So we will have to extract it further. Now coming to another step, that is smelting. Now what is smelting? Smelting again means heat, strongly heating the roasted ore at much higher temperature. And if you remember, smelting is done in a big container known as blast furnace. If you remember, blast furnace had a cup and cone arrangement at the top, from which you can pour what? Three things. That is your roasted ore, coke plus sand. These together is known as charge. This charge is poured from the cup and cone arrangement from the top of blast furnace. Then your blast furnace is passed through a very hot current of hot air is passed through this blast furnace. This furnace has a varying temperature from top to bottom. So what happens in blast furnace in smelting? Actually reduction takes place, and this zinc oxide combines with this coke. This is zinc oxide, it combines with coke. This is coke, part of the charge, forming Zn. And this oxygen combines with carbon to form carbon monoxide. This is a gas. So as a result, we get zinc. So this zinc is pure, but still it is not 100% pure. It may be 95% pure. So this zinc is further purified by the last step. That step is known as refining. The fifth and last step, refining. And as far as refining of zinc is concerned, it is done by electrolysis, and this refining is known as electro-refining. What is done in this step? Just see. The zinc that we have obtained in step number 4, that is still impure. So we will call that zinc as impure zinc. That impure zinc is made one electrode. So this is one electrode. This electrode is known as anode because we connect this to the positive terminal of the battery. So your impure rod of zinc, because this is to be purified, impure zinc is, this has to be purified, it is made anode. Then another rod of the same metal, but not the impure one, this is pure zinc. This pure zinc is made cathode, that is negative electrode, because this rod is connected to the negative terminal of the battery. These are the connecting wires. This is battery. This is the positive terminal of the battery. This is negative terminal of the battery. Now this electrode is connected to negative terminal, so this is cathode. This electrode is connected to positive terminal of the battery. It is known as anode. Now these two electrodes, they are dipped. Now they are dipped in a container which contains the salt of the same metal which is to be purified, that is zinc. So we put here ZnSO4, that is salt of zinc, as electrolyte. This is the electrolyte. This is zinc sulfate in it. Now when here we have a key. When this key is connected, let us find what reactions take place. As soon as we connect the battery by means of this key, what happens? Out of this impure zinc, this is impure zinc, pure zinc begins to dissolve. That begins to dissolve slowly and steadily, and that goes into this solution, that is zinc sulfate. And this zinc, because if this is zinc sulfate, remember please, this is zinc sulfate now. When electricity is passed through it, that is electrolysis of zinc sulfate takes place, it ionizes, that is it forms ions. This is zinc ion and this is sulfate ion. So this is electrolysis of the electrolyte. So as a result of electrolysis of this zinc sulfate, these ions are formed. That is, your salt, your zinc sulfate basically contains Zn2 positive ions and sulfate ions. Now since Zn2 positive ions are positively charged ions, they move towards what? They move towards the cathode and they get deposited at cathode. So pure zinc from here first comes to the solution and then deposits at the cathode like this. Now remember, again I will explain this process. When electrolysis of zinc takes place, this zinc Zn2 positive, that slowly and steadily gets attracted towards cathode, that is oppositely charged electrode, since zinc has positive charge and cathode has negative. So zinc deposits here, and equal amount of zinc from this rod, but pure zinc, that dissolves in the solution, again forming ZnSO4. That is the solution is again formed, and then again what happens? These ionize on as the current is continuing. This again ionizes and zinc ion is formed, and zinc again deposits here. So this process continues. It continues till whole of the pure zinc that first goes into the solution and then moves towards the cathode. And as a result, after some time we will find that your cathode rod will become very thick, because whole of the pure metal from this impure zinc, whole of the pure zinc from this impure zinc rod, that first goes to the solution, then deposits at the cathode, and we can collect pure zinc from this rod. This is pure zinc now. So this is how electro refining is done. So So these are some steps for the extraction of zinc. Here a main point that has to be remembered, that roasting is done at a temperature of 1270 Kelvin, while as smelting, that is reduction, that is done at a much higher temperature, that is 1673 Kelvin. These two are objective type questions. This is smelting, that is reduction at a very high temperature in a blast furnace, while as roasting is done at a temperature of 1270 Kelvins. And one more objective type question, that the chief ore of zinc is zinc blende. That is to be remembered. However, zinc has 5 ores like zinc blende, calamine, zincite, willemite and franklinite. But the first ore, that is zinc sulfide or zinc blende, that is the chief ore of zinc. So these are steps for the extraction of zinc, and that is all for today. Thank you very much.